Now what we're going to do is look at the different laws regarding matter. So one of the first laws that we have is called the law of definite proportion. And the law of definite proportion states that no matter what our sample size is or where we get that sample from, a compound always has the same chemical formula, which we did say when we looked at elements, compounds, and mixtures. Compounds always have the same chemical formula. So water is always 2 hydrogens, 1 oxygen, H2O, no matter if it's a drop from a river or a swimming pool that's filled from your faucet. So doesn't matter where that water comes from. It doesn't matter how much water you have. Water is a compound, and therefore it has a specific chemical formula, and that formula is H2O, and that will never change. So that's the law of definite proportion. So the only way it can change is through a chemical change. But if it's water, it's H2O. If it's something different, so H2O2, that is not the same chemical formula, so that would not be the same compound. So the law of definite proportion tells us this, that no matter what our sample size is or our source, a compound always will have the same chemical formula. Another law of matter is the law of conservation of mass. So that's pretty much exactly what it sounds like. Conservation is kind of like saving. Mass would represent of mass. So what that means is that before and after a chemical reaction, the mass would remain the same. So we said an example of chemical reactions with burning. And so you're like, well, when I burn a piece of wood, the leftover ash is not the same mass as what we started with. It's much, much less. But remember, there's more than just ash that's left behind. You had the gases being given off and smoke being given off. And if we were able to capture all of that and add that all together, it would equal the mass of the wood that was burned. So before the reaction and after the reaction, the mass would remain the same. So the reactants are the things that are before a reaction. Products are the things that are made after the reaction. So in a chemical change, you have the reactants, the things you start with, the things that you're going to add together, and then the products are the things that you end up with after the chemical change. And so those masses would be the same. So if we had carbon and we added oxygen to it, and we were able to measure the amount of carbon, so 12.50 grams, 5.25 grams, we would be able to produce 17.75 grams of carbon dioxide. So it wouldn't be less, it wouldn't be greater, it would be exactly 17.75. We cannot create or destroy mass. So the mass would be the same before the reaction and after the reaction. And that's the law of conservation of mass. Then our third law related to matter is called the law of multiple proportions. So the law of multiple proportions states that even if you have a compound that's made with the same elements, if they're in different ratios, they have, or different proportions, they're going to be 2 different compounds. So a great example of this is water and hydrogen peroxide. So water is H2O and hydrogen peroxide are H2O2. They're 2 different compounds, even though they both just have hydrogen and oxygen. So because they're not the same ratios, there's 2 hydrogens to every 1 oxygen in water, and there's 2 hydrogens to 2 oxygens in every hydrogen peroxide. They have 2 different chemical formulas, so therefore they are 2 different compounds. So the law of multiple proportions, you can kind of think of the fact that we can make up multiple compounds by changing the proportions or the ratios of the elements within them. That's what allows us to make bazillions of compounds and have so many different substances on Earth with only 118 elements. Because if we combine them just a little bit differently, they're going to be a different substance. Another great example of this is carbon monoxide and carbon dioxide. So carbon monoxide is CO. So you have your carbon monoxide detectors. Make sure you check them to make sure your carbon monoxide detector is working. It's a good thing to do every year at your house. And then you have carbon dioxide. So the carbon monoxide detectors do not detect carbon dioxide. They are only designed to detect carbon monoxide because they're 2 different compounds. Carbon dioxide does not kill you. We breathe that in all the time. And obviously we breathe it out all the time. However, carbon monoxide is a different compound, and therefore it has different properties, and that's what can kill us. So that's why we have carbon monoxide detectors, not carbon dioxide detectors. So make sure you check yours. Then we also have 5 laws of matter that this guy named Dalton came up with, and we call them Dalton's laws. So in these 5 laws of matter, some of them are still applicable today, and he came up with these a long time ago. So it's pretty impressive considering the technology that they did not have available at the time, that they were able to come up with these laws. So one of the laws of matter is, this first one is all matter is composed of extremely small particles called atoms, which we know. And then it says, which cannot be subdivided, created, or destroyed. And so then I have the little T/F after it with a question mark. So is this statement still true? Is it false? Well, this statement is partially true, but we would circle a false. So make sure on your sheet you circle false on there, because we do know that all matter is composed of extremely small particles called atoms, but they can be subdivided, because remember, if you think about an atom, you have the protons, neutrons, electrons, and then even further from that, we can divide them into quarks. So we can divide atoms into even smaller and smaller particles. Also, we can create different elements, different atoms by smashing them together in nuclear reactions. So this one would be false, but they are made of extremely small particles called atoms. Then number 2, atoms of a given element are identical in their physical and chemical properties. Well, we learned in our last unit about allotropes, and we know that carbon can have several different allotropes. It could look like a diamond, it could look like the pencil lead, and it could look like charcoal. So we know that they are not identical in their physical properties. Also, chemical properties we know can be changed as well, because we'll get into isotopes and ions. So the chemical properties can be altered within an element as well. So this one is also false. Then number 3, atoms of different elements differ in their physical and chemical properties. Still true today. So sulfur is one element, and it's different than iron, which is another element. So you could see, remember from the lab, we had iron was magnetic, sulfur was not magnetic. They looked different, they reacted differently. So therefore, that one is still true today. Number 4, atoms of different elements combine in simple whole number ratios to form compounds. That one would also be true today yet, because we know that when you combine together, for example, water, we don't say we don't say HO1/2, we say H2O. So we can't have half of an atom. So therefore, we do combine in simple whole number ratios when we form compounds. We're not going to have half of an oxygen combining with a hydrogen. Then number 5 is still true today. It says, in chemical reactions, atoms are combined, separated, or rearranged, but never created, destroyed, or changed. So the atoms themselves are still all there after every chemical reaction. They're just going to be combined differently. So they're never just disappearing. They never just appear out of nowhere. They're just recombined into a different substance. So this one is also true. So out of Dalton's laws, the first and second ones are not true as written, but the third, fourth, and fifth ones would be true. So looking at our first question on here, it says, what is the mass of copper 2 chloride that forms if 1 gram of copper is combined with 0.26 grams of chlorine? And so we see the 2 elements here, copper and chlorine, and we have 1 gram of copper, 0.26 grams of chlorine. Therefore, we know that the mass is going to be the same before and after the reaction. So our answer to this one would be 1.26. It wouldn't be slightly less, it wouldn't be slightly more. It's going to be exactly 1.26, because we're not going to create or destroy any copper or chlorine. The law that supports our answer is going to be the law of conservation of mass. So that's the conservation of mass. That says the mass of a reaction before and after is going to be the same. Then we have CO and CO2. So this is where I said check your carbon monoxide detector because that's the gas that can cause you to die, which would be bad. And then we have carbon dioxide. And these are both made up of carbon and oxygen, but because this is a 1-to-1 ratio and that's a 1-to-2 ratio, these are different compounds. And the law that's going to support this is the law of multiple proportions. So the fact that we can make multiple compounds by having different proportions of the same elements. So we said a 1-to-1 proportion or a 1-to-2 proportion will change the different compounds. Then it says, why aren't all atoms of the same element exactly the same? Don't pick the first one, okay? Because they can form ions and they can form isotopes. So that's what's going to make them a little bit different from each other. We also can have different mass numbers, which is related to isotopes. So they will all have the same atomic number if they're all the same element. That will not change, but their masses can change. You can have fat carbon atoms, you can have skinny carbon atoms. So, but it still would be carbon because the atomic number would remain the same.